All right, so this is going to be the instruction set for the reverse engineering lecture that is being put together for the ST10, well, not linked to ST10 directly, but for the Solid Edge University series for 2017. This has been slightly updated from what was posted up earlier on, but I figured I'd go ahead and walk through all of the materials for you guys along with the demos. As this is what I will be presenting in Boston in the beginning of September. So to get started, just the new enhancements to Solid Edge ST10 for reverse engineering, as well as a bit of an overview of what was previously there. Now for the agenda, what we're trying to cover, what we're trying to accomplish here is to get a general concept of what reverse engineering is, why is it needed, how does Solid Edge accommodate for that, and then go through all of the workflows associated to doing that, so people get a good idea of not only what it is that they're doing, but why they are doing it as well. So first off, reverse engineering, what is it? So essentially reverse engineering is the act of recreating an existing physical part in a CAD system or a CAM system, CAE, or any other software. And this can be done for a number of different reasons. Many people have very customized purposes for reverse engineering parts. One of the primary ones is that they need to have a virtual representation of a part that has already been manufactured, right? They don't have a 3D CAD file associated to it, so they reverse engineer it. One of the ones that I thought was pretty cool was to do wear and tear analysis, comparisons between parts that have been out in the field. So a good example of this is if you had an impeller on a pump that was rated and sent out into the field pushing 20,000 gallons of fluid per minute or per hour or whatever, and then a year later it's only pushing 19,000 gallons. You can pull that impeller off, 3D scan it in, and then figure out where you need to beef up your parts so that you can maintain more efficiency for the future. And then this is also a good time to ask the room if anybody else had experience with reverse engineering, what kind of use cases those were, just across the board, to get some general ideas of the audience that you're working with. Additionally, there are a couple of different ways in which reverse engineering is accomplished, one being physically measuring and reproducing that part inside of a CAD system, right? So going and breaking out the calipers, getting your measurements, and then reproducing that inside a CAD. The second and most prevalent, or more prevalent, the reason why we're focusing more on this now, is 3D scanning technology to scan data in and then import that data into a CAD system. So moving on, basically as scanning hardware and software has become more affordable, it's become more accessible. A lot more people are utilizing it as a method of getting data into a virtual format and essentially using it that way. Now, because scan data is usually read using point cloud data, or basically taking the machinery that you have and getting distances based on the location and having little points in space that is going to relay essentially what is going to become a surface, and connecting those dots to create a mesh, to create a bunch of little triangles that are fit together. There's different ways in which this data is read and displayed. Now, a majority of the material is going to be, or a majority of the tools used are going to be scanned. Those scans are going to be made into point cloud data, and then that point cloud data, it's basically like connect the dots, is going to be converted into a mesh, right? So all of these little points are going to be converted into mesh. Now, most software and hardware has the ability to do this very efficiently as they work with their own native data. However, whenever it becomes mesh, that's when Solid Edge picks up. This is where we focus as a CAD tool to be able to utilize this data and to be able to make edits to it. And that's from importing that mesh into the CAD system, repairing any kind of errors or holes in that mesh, optimizing it, and then using the mesh that you have brought in to identify different regions, identify how you want that mesh to be represented in a BREP format, which is what your CAD system uses for its native data, extracting those surfaces from the regions, editing those surfaces to make sure that everything trims together and intersects properly, and then stitching all of that together to become a solid model that is going to be in that native BREP format for Solid Edge. So a bit of history of reverse engineering and Solid Edge. In ST9, in one of the later MPs, we backported reverse engineering functionality. We had the reverse engineering specific commands, but they only worked with imported mesh data. So those are going to be your STLs and your 3MFs, and it was only available as an add-in. So you had to go and install it and activate it and register it and all that kind of stuff for those commands to work. Now, in Solid Edge ST10, we've expanded the tool set and the type of data that can be worked with. The reverse engineering commands can now work with any mesh data. It doesn't matter whether it's imported as an STL or a 3MF, or if it comes from some of our native mesh that we now create using convergent modeling, such as generative design, lightweighting, optimization. Things that come out of that are going to be mesh data as well, and you can use these reverse engineering tools on any of that. Another area where this is going to be very nice is if you're working with 3D printing, which is also quite prevalent. We're not going to focus on that today, but any kind of 3D printing models that you have, if you need to make some alterations, if you need to delete features off or add some geometry, you can utilize any reverse engineering tools for that as well. On top of that, we've also allowed for some of the curve commands, such as intersection curve and derived curve, to associate two meshes. So this is going to be big if you don't get a full scan or you only get a partial scan of the parts that come in, and you want to be able to utilize what you have to complete it. You can use curves to control where you create your surfaces using those intersection or derived curve commands. Additionally, you can now move and rotate your entire mesh body. So if you want to sit your mesh body in a specific location, whether it's associated to other parts in an assembly or whether it's associated to your origin, you can easily do that now using the sync moves. And it's automatically going to be installed and turned on in product. So you no longer have to do this using an add-in. You get this delivered with Premium and Classic and ready to go, that's capable of being used on any of your mesh data. Now we also have some functionality, some really nice functionality coming out in NP1. At the time of this creation, we didn't have access to NP1. It should be out in the next month or so, but there's a really nice thing coming out called boundary smoothing. And essentially what this is going to do is going to smooth out your mesh. If you have a really rough mesh in a certain area, it's going to automate the process of selecting what mesh you want to smooth, and it's going to make it a lot nicer. In addition to that, we're also going to do some improvements with automatic region detection, and we'll take a look at that in just a minute. So moving right along, one thing to recognize is that, you know, on top of just the reverse engineering commands and the way that we can work with imported or native mesh in Solid Edge, you know, we can. This also gives us a lot of capability when working with mesh data in general. So, you know, we're not going to be talking about generative design. We're not going to be talking about 3D printing during this lecture, but you know, you get great capability in being able to work with this material using those reverse engineering commands. Just something to keep in mind. So the process of, or the concept of the process of working with mesh data is as follows, right? So you're going to import your mesh and repair it so that it's in its optimum form. Then you're going to identify regions. Now this is the step, generally speaking, that a lot of people, you know, it takes a little bit of time to understand exactly what it means by identify regions. We'll get into greater detail when we go through the demo of doing that, but essentially it's automatically or manually identifying what type of surface is going to be created from that mesh. So whether it's going to be planar, conical, cylindrical, B-rep surface, it's going to identify those using colors. So cylindrical is going to be this cyan color, planar is going to be this yellow color, B-rep is going to be this magenta color, and it's going to allow you to automatically extract those surfaces based on what colors and what region has been identified. So from there, you're going to extract your surfaces. So you see we have that plane that was associated to either this plane or this plane. You have your B-rep surfaces here, that are rounded as well as on top. So it's going to automatically extract all of those surfaces, and then you can trim and edit them using solid edge surfacing tools. And once you get everything cleaned up and all of those surfaces trimmed to one another, then you can stitch it up and create a solid model and do whatever you want. Add your rounds, do some finishing touches or whatnot to that model. Now, one thing to keep in mind is as you go through this process, there's a very intuitive and logical flow to the way that the commands are co-located under the reverse engineering tab, where you're going to have your mesh cleanup. Following your import and your repair, it's going to allow you to delete certain aspects if you have some ugly mesh that came across with it, or if you have any holes that you need to fill or patch up. There's a nice automatic command for that. To identifying regions, right? So you have automatic or manual identification, extraction of surfaces, you have your automatic extract or more of your manual fit option. And then from there, being able to edit and trim your surfaces. You have curved surfaces and modify surfaces that are all going to work with making sure that all of those surfaces come together nicely. And then your final command is going to be stitching all of that together. But the natural flow of this concept exists inside of the command layout. So that's something to leverage and make this a lot more intuitive for use whenever you're walking through this process. So first up, we have mesh import and repair. Initially, one thing that you need to make sure of is whenever you import your data, that your settings are set to the proper file units, because your mesh itself is going to need to match the file units of the template that you're using, right? Once you get that mesh inside of Solid Edge, then it's going to be time to clean up that mesh using some of the automated tools. We have Geometry Inspector that's going to make sure that there aren't any issues needing repair inside of the mesh itself, as well as another great tool is using the Optimize. That's going to optimize the body, increase the quality of the model by simplifying your B-spline definitions. It's going to automatically heal edges in case your tolerancing on your mesh body isn't as tight as it needs to be. It's automatically going to fix that. So before we go any further, let's go ahead and take a look at what that first step looks like inside of Solid Edge, or at least part of it. So we're going to go ahead and open this STL file, this MB-0042 STL file. And first thing you're going to notice is that we have a set of options. With those options, we're going to set the file units to millimeters, because that's what our template is going to be. We're going to use an ISO part template. And we're going to get our mesh body in place. Now, one thing to recognize is that our reflection gets a little distracting on the mesh body, so I'm just going to go ahead and turn that off. That's based on my template settings. I'm just going to go ahead and turn off that base coordinate system as well. And then we have our mesh body that has been imported. Now, the first thing we want to do is to optimize this guy, right? So we're going to go to our inspect tools. We're going to run a geometry inspector, and this basically is going to check for faults, small entities, all kinds of different options there. I'm just going to keep all the defaults and run that. No faults were found within the models of the document based on those inputs. the sizes. If you want to have a little bit more precise inspection, you can always knock these guys down depending on the size of your part itself. We're going to accept that. And then it's always a good idea to hit optimize as well. So since I only have one body on screen, we can optimize whether we want to optimize the full body or the simplified body, and then output a report. It's going to go through and it's going to interrogate that entire body. First thing you see is it's going to say, hey, you have a mesh body. You had a mesh body before and you have a mesh body after. That makes a lot of sense. But the important part is that we have this polyline. We had a polyline beforehand, and then after that's been cleaned up. So once that optimization has been done, and by the way, the polyline aspect is when the tolerancing on the mesh, there was a slight gap here, and it basically closed that gap for us automatically, which would have happened whenever we went to the reverse engineering command for fill holes, but it's nice to just go ahead and get all that knocked out. All right, so once we have the initial mesh brought in, we've done the optimization, and we've done the geometry inspection. Now it's time to start cleaning up the mesh to do what it is that we want it to do to have the final outcome. There's some really nice tools for this, for delete mesh and fill holes, and let's go ahead and take a look at those in Solid Edge. So we're going to go to the top side view and zoom in, and we don't want this little boss, this protrusion, as well as this hole in here. So we just want to delete all of that mesh out. So the command delete mesh is essentially going to give us options. So we can select mesh facets or the entire mesh. If we do the entire mesh, it's just going to pick up everything. If we do the facets, it's only going to do portions of that. So if we go to block, it's going to select little portions. As you zoom in, you can see the individual mesh being picked up there on the brush. Another thing to recognize is that, I hate that thing being highlighted. Another thing to recognize is that with box, it's going to go all the way through the mesh. So not just this side right here, but all the way through to the other side. If you don't want that, if you just want one part to be deleted, use brush. But we're going to go ahead and delete out both sides because this hole is existent on the other side as well. So go ahead and click and drag out and fence select this, and then when you right click to accept, it's going to automatically delete all of the mesh that has been highlighted, and you can see that it deleted across the board, throughout the entire thing. So we have a hole in the front and a hole in the back side, deleting that feature out of there. Now next up is the fill holes command. It's not really necessary in this demo, but it's a great thing to be able to show that Solid Edge automatically picks up holes and can fill those in. We'll take a look at why it's not necessary when we look at the regioning portion of it, but we'll just go ahead and hit fill holes. You see it's automatically going to highlight where the holes are. If you click on settings, it's going to show them and highlight them individually. If we wouldn't have run optimize, there would have been a third hole here down here on the bottom where it would have filled that out as well. We're just going to go ahead and accept both of those, and it's going to go through. It's also going to give us a layout of exactly how we want to fill these. So we can do refine, tangency, linear, any way in which we want to fill those holes. So we'll go ahead and get those guys done using that fill holes command. And we've cleaned up our mesh. We've got it in the state that we want it. We've removed unwanted features from it, and now it's time to start converting that into a BREP model. So the first step in doing that is to identify the regions that you want. And essentially what that is going to allow us to do is interrogate the mesh itself, interrogate the mesh areas, and try to decipher what type of surface wants to be used for that. There's two different ways to do this. You can do it automatically or manually. Essentially, automatically is going to interrogate whatever mesh that you pick up, and it's going to highlight in certain colors. So inside of the Solid Edge help, there's a nice layout of exactly what these mean. So if it's going to be a planar construction surface, it's going to highlight in yellow, so this is going to be identified as planes. Cylindrical is going to be cyan, Conical is going to be blue, so if it has kind of a cone shape to it. Spherical is red. B-spline or freeform, if it doesn't have one of these more prismatic shapes, it's going to show in that magenta color. And then if it's non-extractable, it's going to come through as white. Additionally, you can set the accuracy of how you want to identify the mesh. The higher the number, the higher the accuracy, essentially meaning it's going to take smaller subsets of this mesh to identify the region areas. So I personally like using a lower accuracy because you get a more generic outcome as seen here. If you use a higher accuracy, you're going to need a higher accuracy tool for the mesh generation. You know, whatever your reverse or your 3D scanning software and tools, you know, if you have very high accuracy, you can use a higher accuracy here and it's going to pick up properly. But for the tools where it's going to give you a rougher mesh, it's always nicer to bump that accuracy down. Additionally, you have a manual option to allow you to manually identify the type of geometry you want to use on any mesh. So essentially, it's going to allow you to paint these faces whatever colors you want to, or if you want to identify something separately from one of these common colors, you can do that as well, which we'll do right now. So the first step is going ahead and hitting automatic. We're going to bump the accuracy down to 3, which is a good number, and then we're going to go ahead and select the main part of the mesh. Now the reason it didn't matter whether or not we accepted these guys right here is because this plane is going to use the extents as long as this surface is connected to one another, or as long as this color region is connected to it, it's going to use those extents, and it's going to automatically close that in for us. Another thing to keep in mind is if I there's a little bit of an issue with RTM. It's not an issue, it's just the difference in recognition. And when I said there were improvements for MP1 on the automatic recognition, this is what they're improving, is that this face sometimes, just like in the PowerPoint presentation, is going to show up as blue, and then sometimes it's going to show up just like this. And the only difference is that it depends on which time you run it. So if you see this in blue when you're running through it, don't worry. It's going to give you the exact same capability as far as painting it the way that you want it to, and it's not going to affect your demo really at all. So we're just going to go ahead and accept that. Whoops. Run that again. I hit escape. Accept that mesh. And of course we could go and paint these faces here, but that's not going to be necessary. It just takes a little bit extra time. But once we get that done, we notice that we have, you know, the red for the cylindrical, all the planar faces, or the red for the spherical, the cyan for the cylindrical. But we need to make some changes to this front face here because it's picking up a B-spline, but as I told you earlier, it's where all of the extents of that B-spline go, and we don't want to have a surface that tries to accommodate for all of these curves right here. We just want this top face surface. So we need to do some editing on this guy right here. And that'll make more sense in just a minute as well. But essentially what it allows us to do is go through and manually paint whatever we want to whatever color. So I'm going to go ahead and make this kind of this green here. And also it gives us different options. So we can use a paintbrush, we can do a fill. So, you know, if there's something that's completely encapsulated, we can use that as a fill. We don't want to use fill for this portion right here because obviously it's going to pick up everything around the edges. So I'm just going to go and paint the remainder of this. Right, so I'm going to hit the edges, click and hold. And then all you want to do is make sure that the entire color touches one another. So you don't have to worry about filling in all the holes. You don't have to worry about making sure that everything's perfect. You just want to make sure that that all of the color is connected all the way through, so that whenever you go to select that, it's going to know what surfaces you want to use for it. All right. So we can go ahead and accept that. Also, there's another command in here called non-extractable, and this is basically going to color that mesh clear. If you make it non-extractable, it's going to make it not a region for pickup on the automatic recognition. So we'll go ahead and accept that. and you see it's going to paint that front face and give us a nice curve here on the front that we'll be able to use to extract that B-spline curve. All right, so that is the portion of this which is going to be for identifying regions, right? So we've got all of our regions identified. We've painted our front face. I just used a different color than this magenta because if I would have used magenta, it still would have blended into everything. But I want to create a nice B-spline out of this front face as well. Now, once the regions are identified, the next step is using those regions to extract surfaces. Okay. So there's ways to do this, which is going to be an automatic method, and then there's ways to do this, which is going to be a more manual method. And we're going to take a look at both of them. So the first way we're going to do is going to be more of an automatic method. Okay, so we're going to come up to the extract command, and basically what this is doing is it's saying, you know, we're going to use the color of the regions to give you the shapes that those colors represent. So if I click on this, it's going to create a plane of that region. So I'm going to go around and select all of these planes because all of these faces are going to end up being planes. And what it's going to do is it's going to use the extent of those colors on those planes, or on those regions rather, to place those planes. So this one's going to have a plane that has, you know, an overhang of a certain percentage. It goes all the way around where that region lies. The same all the way across the board. So let's go ahead and pick up this bottom face as well because that's going to be a nice plane. And then next we want to pick up the sphere because that's going to be just a nice spherical shape as well. And then we want to pick up the cylinder. Now you might be asking yourself why we didn't pick up these guys right here, because we need planes on the bottom. Because exactly what I said, right? This is only going to create a plane around the outside of this region. So rather than having one plane on the bottom, we would end up having 4 individual planes, which is not what we're wanting. And for this front face right here, it's not picking up because it's not one of the common colors. So we're not going to be able to extract that because it doesn't know what to extract it as. So that being said, we can just go ahead and hit the extract button on this. It's going to go through and it's going to interrogate the model. It's going to look at all of the regions that we have highlighted and automatically place those planes where they're going to be located. Now if we turn off our part copy, you can see that we have, you know, the 4 edges around, we have the bottom, but we still have a couple of regions that we need to fill in based on our model. So I'm going to go to a top view and we need to fill in this outside edge, but we only want to use a single plane to do that. So I'm going to hit the fit, and the fit, it doesn't matter what color you have there, you're going to be able to select whatever surface that you want. There's a tolerance based on the mesh distance. You just leave that as default, and I'm going to hold the control key and go around and select all 4 of these areas. And when I right click, it's going to use the extents of all 4 of these together to create that surface. So we're going to have to do that for that top face there. It takes just a minute to get those extents worked out. And you can see that we now have that surface that's been created. Go ahead and go back into top. And you can also select whatever boundaries you want, right? So this mesh was rough enough to where it didn't pick all of this surface up as a single plane, or all of this region up as a single plane, but we can go through and select all of those individual nodes or all of those individual sets of mesh, and it's going to use those as boundaries to create a surface on that top face. So that's what the fit command allows you to do, to go through and manually set whatever surfaces you want. And then finally, we've got this one, we've got this one. We want to go and create a B-spline, but we want to create it using that front face that we painted. It's going to interrogate exactly the location where that painted face is, the mesh that is associated to it, and it's going to create a nice curved surface for us to utilize. So now whenever we turn off that part copy, you can see we have a very nice representation in kind of a rough format of exactly what that shape is going to look like. So very easily we've gone through. Solid Edge has pretty much manually picked up all of these regions for us, and then transferred those and turned those into surfaces that are going to be BREP surfaces that we can modify. If we want to take this and change it to 115, we can do that because it's Solid Edge data. Additionally, change this to 185. We can do that as well. Now, it's important that you pick up on the messaging of that, of being able to make these edits, but it's important that you do that. If you leave this the same size, you're not going to get a nice cylindrical face. This side over here is going to trim to the outside, and it's not going to allow you to edit that once you turn it into a Solid Edge part. And on the bottom here, it's going to not be completely outside of these trimmed faces whenever you get done. So just make those changes, move this to 115, this to 140 or 185, and whenever you turn it into a Solid Edge model, you won't have to worry about Synchronous being able to figure out exactly what those shapes are, because they're not going to be overlapping or consuming faces. All right, so that is the extract surfaces area, or the extract surfaces step. And then finally, you're going to want to edit and trim your surfaces down so that you can stitch it all together. Right now we just have different surfaces that are overlapping one another. We want to make sure that those are trimmed and cut to each other so that we have one solid body left over that we can stitch together. Now this is going to be the most tedious part of this demo. It is quite easy when you know which clicks to create, but I would highly suggest practicing this, because if you accidentally trim out something or don't trim out something that you should, it could be a bit of a faff to get the whole thing to stitch together. So we're going to first off utilize the modify surfaces extend option, and we want to make sure that the top of this, the top edge of this cylinder and the bottom edge of this cylinder will overlap those two planes that we created. So you can click them both at the same time, right click to accept, and then just drag them up so that they overlap the top and bottom. Right click again, and then we want to do the same thing for these right here. So we want to make sure that these planes all are intersecting, and depending on what your first selection is going to show the direction you need to drag out, right? So my first selection was this inside face, or this inside edge, so I drag outward to make it larger. And then down here, I'm going to pick up this outside edge because that one's much easier to see. You can select through the part, then drag outward, right? You don't have to drag inward, drag outward so that everything intersects. And then we can do the same thing with this edge, just push it into the middle just to make sure that that everything is intersecting. And we'll do the same on the other side. Now it might seem a little bit repetitive, but just keep in mind that if you were to do all of this manual creation yourself, it would take a huge amount of time, and here in just a couple of seconds we were able to get all of these planes in the state that we need them. And then at this time we just go through and hit the intersect option and start selecting the areas that we want to cut out. So first up, I'm going to select the sphere, the top face, and then all four sides surfaces as well. So we're going to take care of this upper area. Right click to accept, and I like to use my planar views. Use your view cube because you can go around. It's much easier to visualize exactly what you're trimming out here, because this part gets tricky if you're looking at it from a different angle, because all of these little surfaces that intersect are options for being trimmed out. So go ahead and use your planar views. Zoom in tight if you need to, which are basically taking out all of the edge conditions. And go to the other side, planar view, and trim all of this away. That way, whenever you take a look at it, if you're from a side, these guys get a little bit difficult, or if you're from like an isometric view, these guys get difficult to see. One other thing that you want to do is trim out on the inside. So you can select the bottom half of the sphere, and then you also want to select the planar region underneath that. So this is going to automatically trim into itself. It's going to be like a hollowed out surface, complete hollowed out surface when you're done. So once we get the top done, then let's do the bottom. So you're just going to select the cylinder and then these two planes. This one's pretty easy. You're just going to select the top edge, the bottom edge, and then the outside areas of that middle plane. It's automatically going to trim. And you can see that if we didn't change this to 115 and we didn't change this to 185, there would be a bit of intersection taking place around the edges, so that's why we did that. This next part is going to be one of the trickier parts. You're going to do this in 2 stages. So first you're going to do everything on the outside of the body. So you're going to pick up the 4 sides and the front, and then you're going to trim those against each other. So don't select this front face first. It tends to be a little bit more than I can visually handle at one time. I guess if you get good at it, that's not a problem. But once again, go into a planar view and trim out the outside edges. So we're wanting to keep this surfacey area here. So just trim out the outside edges. Like I said, make sure you practice this. It makes things a lot easier down the road. And then we can come in and select the other areas. So this direction. Go ahead and get those slivers. Right, and you have to pay attention as well because there's a couple of the little guys left over, depending on how accurate the original set is whenever you create the surfaces themselves. So it looks like we got everything taken care of here on the outside edge, and then go ahead and right click, and you'll notice that we've got all of our surfaces trimmed together. And then finally, well, not finally, we've got one more step after this. We're going to trim those 4 edges up against that face, and just go to a back view and go to a top view, or whatever the view name is. And you can see that we've got everything behind that trimmed away. Another area of concern is going to be that back planar face as well. So just go ahead and make sure you get that guy, so that this is a hollowed out area just like this cylinder was. And then finally, we want to make sure that everything is trimmed up in the bottom here. If you go to the cylindrical surface and you click at the planar surface right above it, right? So it's not always going to be planar surface 8, but it's generally the planar surface right above cylindrical surface. It's going to turn off the bottom face, or the bottom surface, and then you select the bottom and then the 4 corners, so that you can go through and you can trim away the excess, as well as this area right here. So you have one solid surface that's all trimmed to each other and hollowed out in the middle. And this is the output that you're looking for, right? So you want to make sure that you have a final output that looks like this, everything trimmed away properly. And once again, somebody might say that's a little bit tedious, but think of how long it would have taken to create this, especially with this curved face here with the B-spline. If you didn't have these tools, in maybe 10 minutes, we're going to have a final solid edge body directly created from this. Of course, the final portion of this is stitching and creating your solid model. So at this point, going back to the model itself, modify surfaces, it's a little off the screen, but hit stitched. Then select the entire thing, right click to preview, right click to finish. You'll notice that it's going to show up in our construction body container as solid body 16. Double click to activate it, right click, toggle design construction, and we have our solid design body that is going to be a sync body. You can easily make any kind of modifications that you want to. That's not what I was looking for. I was trying to hit this 185. Oh my goodness. Trying to hit this 185, and then you can just scroll it, show them that it's a synchronous body. You can add rounds to it. You can do whatever you want to. It's now native solid edge geometry, VREP geometry that you have full access to. Now that's showing the process of everything that has taken place inside of the slide deck. In case people get these at the end of the at the end of the show or at the end of your lecture. There's reference information based on all of the different commands that are available, to show exactly how everything works, in case they want to use it. So feel free to have that reference information available, but I wouldn't recommend going through step by step all of the different commands, especially when we're just trying to get that concept of exactly what the process is for all of the people to be able to use. So that's it for the reverse engineering 1 hour lecture, and hope it works out well for you.